Now we're also going to use our critical values / rejection regions approach, which, remember, starts out the same way. You still do the same thing. You still start out by identifying your claim, figuring out your H0 and your H1, figuring out if you have a right-tailed, two-tailed, or left-tailed. You still sketch a graph. It's still going to be a chi-squared graph because you're still going to be testing something for the population standard deviation, for sigma. So you'll still use your chi-squared graph, which again, remember, starts at 0. The difference is you're going to create a rejection region. Well, first of all, you want to find that test statistic to figure out if it's going to fall in the rejection region. If it does fall in the rejection region, you will reject H0. If it doesn't, you will fail to reject, just like before. So we're still going to use the formula that we used in the p-values approach to find the test statistic. It's the n-1 times the s squared over sigma squared. That test statistic, though, is what we're going to need to determine, is it in the rejection region? Well, we haven't even talked about how to find the rejection region yet. Well, how do you find the rejection region? Well, you're going to find the rejection region by, let's see, remember the rejection region is determined by using your alpha, and your alpha is going to fill in the area in the tail or tails, depending on if it's one-tailed or two-tailed. And then you're going to have to work backwards and use your table, your chi-squared table, to find the values for the rejection region. So be careful. If it's two-tailed, you have to actually split out that area between the two tails, which means you'll need to cut it in half. If it's a right-tailed, we'll just get to stick the area in the tail and look that up. Be careful if it is a left-tailed test, because if we go to use our chi-squared table, remember the chi-squared table is the only special table that uses the area to the right. We're so used to having tables use the area to the left. This is the only one that uses the area to the right. So when we're coming up with our critical values that make up our rejection region, we have to keep that in mind. Then, once we have our rejection region, we want to see, well, does my test statistic, the one I use my formula on, does it fall in the rejection region? If it does, then we're going to reject H0. If not, then we fail to reject H0. Once you've decided that, then you need to figure out what does that mean about your original claim. Is there sufficient evidence or insufficient evidence to either reject or accept your original claim? So the actual testing part is pretty much the same. It's the same bones and the same outline. The only difference is the actual test, and the fact that if you're testing something for the population standard deviation sigma, we now have to use chi-squared, and the calculator just can't help us as much.